Now in the previous lecture, we have implemented creation of queue using linked list, isEmpty method, and enqueue method. Now in this lecture, we are going to implement dequeue method, pick method, and deletion of queue. Now let's get started to implement dequeue method. Now we know that in case of queue, the queue method returns the first element from the queue and removes this first element from the queue over here. Now that's why I'm going to create our dequeue method with the return type of integer, and it will not take any parameter. Now then inside this dequeue method, the first thing that I'm going to do, I'm going to create a value which will be the return value. So this has to be the value of the integer type. So I'm going to set it to -1 because when we don't have any element in our queue, in this case we cannot dequeue any element. So in this case we are going to return -1 over here. Now otherwise, the first thing that I'm going to do, I'm going to check that if queue is empty or not. So if queue is empty, we cannot dequeue any element from here. So we are going to print out to the console saying that the queue is empty. So if it's empty, then we are going to print out to the console saying that the queue is empty. So this means that if our queue is empty, there is not any element to dequeue from this queue over here. So that's why we are going to return the value of -1 because we are not assigning any value to this over here. So at the end, we are going to return this value. Now otherwise, if the queue is not empty, we have to return the first value from the queue and we have to delete that value from the queue over here. Now we said that we are implementing the queue using linked list. So to access the first value, if we access the head value in the linked list, we are going to access the first value. So that's why I'm going to set to this value that we created over here, the value of head. So list.head.value. So in this case, we are accessing the first element in our linked list. Now then, we need to delete this element from the list. So I'm going to call deletion of node method with the index of 0. Now when we are creating linked list class over here, we said that we have implemented deletion method over here. So as you go to this class over here, you can see that there is a method called deletion of node. And this method takes one parameter, which is location parameter. So if we put as location 0, it's going to delete an element from the beginning of the linked list over here. So here we are just changing the head reference from pointing to the first node to the next node. So with this, the first node becomes available for garbage collection. So garbage collector deletes the first node from the memory. So with this part of code, we have successfully deleted an element from the beginning of the linked list, which means that we are deleting first element from the linked list. So that's what we need in case of the queue method. So that's why we are calling deletion of node with the index of 0. Now after doing so, I'm going to return value. So in this case, if the queue is empty, it's going to return -1. Otherwise, it's going to return the value that comes from this head value over here. Now with this, we have successfully created our method. Now let's see how this is working in practice. Now here inside main class, instead of isEmpty method, I'm going to call dequeue method, and the result should be the type of integer. And then we are going to print out to the console this result. Now we know that we have inserted 3 elements in our queue. So the first element in our queue is 10. So if I run the queue method, it should return 10. Now in this case, you see that after enqueuing 3 elements, when we call the queue method, it returns 10. Now if I call the queue method one more time, in this case, you are going to see that it's returning 20 because the second element is 20. Now after deleting 10 over here, 20 becomes first element. So when you run the queue method one more time, it's going to return 20 in this case. Now let's run our code. Now you see that when we run the dequeue method second times, it's returning 20 over here. So our method works perfectly. So we have implemented this method successfully. Now let's see what's the time and space complexity for this method over here. So as always, we are going to start from the first line of this method. So in the first line, we have created variable and we have set -1 to it. So this one will take O1 time complexity. Then in the second line, we are checking that if this queue is empty or not. So this one will take O1 time complexity because we know that isEmpty method in this case takes O1 time complexity. Then inside this if condition, we are printing out to the message saying that the queue is empty. So this printing out message to the console takes O1 time complexity. Then inside in the else condition, we are assigning head value to this value over here. So this is just simple assignment statement. So this one also will take O1 time complexity. Then after doing so, we are deleting element from the beginning of the linked list. So this means that it will take O1 time complexity because when we learned the single linked list, we said that deleting an element from the beginning of the linked list takes O1 time complexity. Then at the end, we are returning value. So this one also will take O1 time complexity. Now, if we combine all these complexities over here, we get O1 time complexity. Now the space complexity is also O1 because here we are just deleting an element from the beginning of the linked list. So this means that it will take O1 space complexity because an extra space is not required to perform these operations over here. Now with this we have successfully implemented the Dequeue method. Now let's continue to implement the next method, which is pick method. Now we know that in case of queue, pick method returns the value of the first element in the queue, but it's not deleting that. But in case of the Dequeue method, we said that we are deleting element from the beginning of queue and we are returning that value. But in case of pick method, we are just returning the value of first element without deleting it. So this means that I'm going to declare our method like this with the type of integer because we have to return the value of the first element. Now in this case, we have created integer queue, so that's why the return type of this method will be integer. So the first condition is we are going to check that if the queue is empty, so in this case we are going to return -1 because the queue is empty. So before returning it, I'm going to put to the console saying that the queue is empty, then we are returning -1. Otherwise, in the else condition, we are going to return the first element from the queue over here. Now we know that first element in the queue is located at the head value of the linked list, so I'm going to put it like this: return list.head.value. So with this, we have successfully implemented pick method in this case over here. Now let's see how this is working in practice. So here I'm going to call pick method instead of the Dequeue method, and I'm going to call it twice to see that how this is working. Now in case of the Dequeue method, first it returned 10, then it returned 20 because 10 is removed from the beginning of the queue. Now in this case, in both cases, it should return 10 because in this case, we are not removing the element from the queue over here. We are just checking the first element. So now as you can see, it doesn't matter how many times we are calling pick method, it will always return the first element without deleting it from the queue. Now with this, we have implemented pick method successfully. So let's see what's the time and space complexity for this method. Now, as always, we are going to start from the first line. So in the first line, we are checking that if this queue is empty or not. So is empty method takes O1 time complexity. So this line of code will take O1 time complexity. Then we are printing out to the console this message. So this one also will take O1 time complexity. Then returning -1 also takes O1 time complexity. Then in the else condition, we are accessing the head value and returning it to the console. This one also will take O1 time complexity. Now, if you combine all these complexities over here, it takes O1 time complexity. Now the space complexity is also O1 because here space consuming operation is not performed. So that's why the space complexity is O1. Now let's continue to implement the next method. So the last method of this lecture. So here the last method will be, we are going to implement delete queue method. So I'm going to put it like this, delete. So this method will not return anything. So that's why return type I'm putting void. So the name of method will be delete queue. So this method is not taking any parameter because here we're just deleting the queue from the memory. Now, in case of linked list, to delete the queue, we have to delete the linked list from the memory. Now we know that in case of single linked list, to delete linked list from the memory, all we have to do, we have to set head and tail references to null. So with this, all nodes in the linked list becomes eligible for garbage collection. So garbage collector can come and delete these nodes from the memory. So in this case, that's why I'm going to just set head to null, the head of this list that we created over here, and tail to null. So I'm going to put list.tail equals null. Now with this, we are deleting a link between head value and the first node and a link between tail and last node. Now, after doing so, all nodes becomes eligible one by one for garbage collection. So because first node is not referenced by any node, so this means that's going to be available for garbage collector. So garbage collector deletes first one, then the second one, and it continues like this until we reach the last node. Now after doing so, I'm going to print out to the console saying that the queue is successfully deleted. Now with this, we have implemented delete queue method. Now let's see how this is working in practice. So here after in queue method, I'm going to call delete method to see how this is working. If I run it, now you see that at the end it's printing out to the console saying that the queue is successfully deleted. So we have deleted our queue successfully. Now let's see what's the time and space complexity for this deletion over here. Now the time complexity will be O1 because all 3 lines of code over here takes O1 time complexity. Here we are just setting head and tail references to null and printing out message to the console saying that the queue is successfully deleted. So all these 3 lines of code will take O1 time complexity. So that's why the time complexity is O1. Now the space complexity is also O1 because because here we are just setting the head and tail references to null, so this means that all nodes will be deleted from memory. So an extra space is not required to perform this operation, so that's why the space complexity is 0.1. Now with this, we have come to the end of this lecture. So in this lecture, we have implemented the queue method, pick method, and delete queue method. In case of queue, using linked list. So hopefully everything is clear about these methods over here. Now see you in the next lecture.